NASA spent $10 billion on one telescope, and its first deep-field image quietly contradicted our best model of the universe. The picture looked beautiful. Thousands of galaxies were scattered across a patch of sky smaller than a grain of sand held at arm's length. But hidden inside that light was a problem cosmologists are still arguing about today. The image was not just a postcard from space. It was evidence that something in our story of the universe does not add up.
Here is the part nobody dwelled on at the press conference. We did not simply take a pretty photo. We took a photograph of the past. Light from those galaxies traveled for billions of years before it ever touched the mirror. The faintest smudges in the frame show the universe as it was when it was extraordinarily young. And those infant galaxies were doing something they should not have been able to do. They were already old. They looked finished. They looked like they had skipped the beginning entirely.
Start with how this telescope sees, because it changes everything. The universe is expanding, and that expansion stretches light as it travels across space. Visible light from the very first stars gets pulled into the infrared, invisible to human eyes, and to the older telescopes that came before. This observatory was built to catch exactly that stretched light. Its golden mirror is larger than anything ever sent to space, and it sits roughly 1 million miles from Earth, shielded from the sun and frozen near absolute zero, staring into the dark. The deeper it looks, the further back in time it sees. Point it at a single empty patch of sky long enough, and ancient galaxies slowly emerge out of the noise. That was the entire plan. Look back toward the beginning and watch the first structures gradually assemble, step by patient step. Gradually. That one word is about to matter. Our best model says the universe began simple. After the Big Bang, there was only hot gas, mostly hydrogen and helium, spread almost perfectly smooth in every direction. Gravity needed time to pull that gas together. First tiny clumps, then the first stars, then small ragged galaxies. The grand spirals, like our own Milky Way, are supposed to be the end product of billions of years of collisions, mergers, and slow, steady growth. So when we look at the first few 100 million years of cosmic history, the model is confident about what should be there. Faint, small, scarce, barely formed islands of light just beginning to switch on, one dim ember at a time. For decades, that prediction sat untested because no instrument could see far enough back to check it directly. This telescope finally could, and it pointed straight into that early window. What it found should not exist. In that earliest window, only a few 100 million years after the Big Bang, the telescope saw galaxies that were too big, too bright, and far too mature. Some appeared to hold nearly as many stars as the Milky Way holds today, packed into a tiny fraction of the time the model allows for building them. These were not faint smudges struggling to ignite their first stars. They looked established, structured, already grown. Several glowed a strange deep red, compact points of light far too luminous for how young they were. And the real problem is the math. To assemble that many stars that quickly, the early universe would have had to turn raw gas into stars at an efficiency our physics simply does not permit. The galaxies were undeniably there in the image. The time needed to build them was not. So physicists started scrambling, and none of the explanations are comfortable. Maybe the earliest stars were monsters, far more massive and brilliant than any star today, making their galaxies look far heavier than they truly are. Maybe star formation in the infant universe ran at an efficiency we never observe in the modern cosmos, converting gas into stars almost recklessly. Maybe some of that intense red glow is not starlight at all,
but superheated gas spiraling into enormous black holes that somehow grew impossibly early. Each idea patches one hole and tears open another. And underneath all of them sits a quieter worry. These distances depend entirely on reading how far each galaxy's light has been stretched. Get that measurement wrong, and a closer galaxy can masquerade as an ancient one. A handful of the first candidates were quietly revised once the careful follow-up observations arrived.
But the tension refused to disappear. The slow, careful measurements, the kind that split a galaxy's light into a full spectrum, have now confirmed that some of these objects really are as distant and as early as they first looked. That is what lifts this above a simple glitch. The standard model of cosmology is extraordinarily successful. It predicts the faint afterglow of the Big Bang and the vast web of galaxies threading through space with almost unreasonable accuracy. It was never built to be fragile. And yet, here is a single deep field image quietly suggesting that the first chapter of cosmic history unfolded faster than the model can account for. Nobody is throwing out the Big Bang, but the timeline, the careful, ordered sequence of how everything came together, may need to be rewritten. And the data keeps pouring in. Those strange red points of light hide a second mystery, and it may be even bigger than the first. If some of them really are black holes, then they grew to millions of times the mass of our sun almost immediately after the universe switched on. And no one can yet explain how a black hole gets that massive, that fast, with so little time to feed. Next time on Quiet Cosmos, we follow that red light deeper into the dark and ask how the first monsters could have formed before there was any time to form them at all.